How's everyone doing this Wednesday afternoon? Doing okay? Keeping warm? Let's see. It's a little warmer out there today. What's it say on my phone here? 48 degrees. That means it almost has a 5 in it. But 48 degrees currently. Oh no, 52 degrees. It just updated. It hadn't updated. 52 degrees. That actually doesn't feel so bad. In fact, it feels like a heat wave considered to what we've been going through this month. But we'll take 52 degrees. I feel like taking my shirt off, running around the schoolyard. But nobody wants to see that. That's not gonna happen. So, but yeah, so don't. I'd be all over Instagram and TikTok probably if that happened. So yeah, we're not doing that. But 52 degrees, man, that sounds fabulous. It's like woohoo! I'll go out and sunbathe or something out there in the lawn chair, and no, it's not that comfortable out there, but it does feel good. So, hey, I do have a video I want us to start off with today. It has nothing to do with algebra, absolutely nothing, but that's okay because we like to kind of have some fun from time to time. No, I found this video today. I stumbled across it. I'm always doing something online. And I said, okay, now that's cool. So I'm going to show you this video just because I think we need more of this in the world. I would love someone to build this, put it in the cafeteria or put it in the downtown square. Just this needs to exist around our area. So let me put this up on the screen and I will. Let's see. I have to share this story. You can hear the audio. So that's a little different. Okay, the audio. All right, so I'm going to share this with you just because, like I said, we need more of this in the world. I'd love for someone to do this, to build this, and for it to exist around our area of the world. But this is cool. Take a seat and make a friend. All right, here I'm going to maximize this. It's just 5 minutes. We'll take 5 minutes to look at this because I think it's pretty cool. But all right, here we go.
I have never, ever been in a ball pit before.
What?
You've never been in the ball pit?
No, never.
You gotta go.
No, I've seen them, but I've never been in one.
You know, I remember these ball pits because my kids threw up in them.
Yeah.
Okay. All right, so let's see.
Okay, this is a good one. Share 3 things on your bucket list.
First one is to go skydiving.
I want to go skydiving.
Have you ever had those dreams where you're just like floating and, you're flying and everything? Scuba diving is just exactly that.
Don't you get afraid of drowning or being underwater, or getting attacked by an octopus, or any of those things?
I want to learn curling,
What is it?
like that Winter Olympic sport.
Oh, all right, where you slide the
Yeah,
puck thing?
and then it's like bowling and sweeping.
Find one thing you have in common. Do you play sports?
Not currently. I play soccer, so.
Soccer?
Yeah.
All right.
Actually, I play the drums. Do you play any instruments?
I quit everything I ever tried.
All right.
Actually, fun fact, these aren't real teeth. Yeah.
I have a flipper tooth.
Really?
Ah! Oh my God! No! I can't. Wait.
What?
My front tooth.
Oh my gosh.
What? You don't even understand. I swear to God, I feel like someone planted us here for this reason.
Destiny.
Describe the first time you fell in love.
Oh, I think it was kindergarten. I don't remember his name, but he was beautiful.
I was in the Navy,
You were in the Navy?
and my husband was in the Navy. Long story short, before he ever kissed me or we were ever really together, he told me he loved me. 24 years later, we're more in love and we're better friends than even from the very beginning.
That's true love in its finest. Talk about someone who inspires you.
Is it all right to talk about somebody that's a religious character?
Yeah, why not? This is our ball pit. We can talk about whoever we want, right?
Jesus.
All right.
Just my peers. They're all creative in their own ways and have their own realities and own lessons. I just
grow from everybody else's as well as my own.
Martin Luther King, I think, because the fact that we're sitting in this box together is a big deal, you know? Like,
You know who inspires me, believe it or not, is my daughter. She is everything I ever wanted to be.
All right. Talk about the experience that changed your life. Oh, that's a good one. After my wife decided that it was time that we split, I started to have a different perspective on life. I saw women differently. I saw relationships differently. I think I became more appreciative of women.
How old did you say you are? 20?
Yeah.
Okay. At the age of 21, I was diagnosed with multiple sclerosis. And it pulled the rug out from all my plans. It really changes the way you look at things.
My grandmother has it.
Who does?
My grandmother.
There's our comment.
We found the comment.
We found the comment.
That's why it was still here. We found the comment.
oh, create a secret handshake. Okay.
Okay, but nothing with spit.
Okay, so that.
I need both hands.
Okay.
So this.
And then whoever gets on the top makes a flag.
Oh, now I forgot what it is.
And then like maybe a little twitch in the middle.
1, 2,
1, 2.
High 10. All right, we did it. Awesome.
I actually had a lot of fun. I was a little bit nervous because normally you don't hang out with strangers in ball pits. I got to learn some pretty cool things about you.
It was really nice to meet you.
You too.
I hope I see
I'll
you
take a
again.
look.
Okay, I love it.
I'm really impressed by you. I was worried that I would start talking to you like a mom. I don't know if I did.
No. Nah, you
No.
didn't. Trust me. You did good.
Subscribe. Would you do that? Would you go get in the big ball pit? Would you go sit there just to make a new friend? Don't you think the world needs that? See that?
I would.
Yeah, I just think that would be the coolest thing. I think somebody needs to build that and have it in downtown square or even the school cafeteria. I think it'd be cool. You know, don't get in there with your friends. That ruins the whole thing. That's not the purpose. You get in there with somebody you don't know and you make a new friend. I just think we need more of that in the world. So I just wanted to show that video just to get us started off, give us more hope in humanity, you know, because we hear all the bad stuff all the time. Well, that makes the viral, you know, all the time. It's a viral thing on every social media. But seeing the cool things like that. I saw another one that I think would be neat. There was one that was like where you give a compliment to someone, and it was out there on the sidewalk, just like this big box was, and it had like a phone booth, and you could get in the phone book, and there's a microphone, and you could see outside of it. And on the other side of the sidewalk, there was like these huge headphones, like it was like a big speaker. It's like you stand between these headphones, and the person in the phone book compliments you. And they give you a compliment. And those were most of the people that use that were like, they were friends, or it was husband and wife, or it was, you know, best friends. And so, and then they would trade places usually and give them compliments back. And it was cool. You just sit there and listen because you didn't have a microphone to speak back to them. They were in the phone booth so it was pretty neat. But anyway, find those things. I just get inspired and thinking, yes, more of that. So, all right, we're going to take a look at our curriculum today, see what's going on. Third hour, Algebra 2. We'll get this up on the screen if it cooperates with us. Go to our grade screen as usual and see fake student. He did not ace his assignment. He may want to redo it. You get 3 attempts. He got 90% on his first try. So Mr. Fake Student here that we look at every week. He's got an A. He's doing all right. But he may go back and use a second attempt to try that. But looking at what's due, this week we have 2 things. We have 5.02 logarithmic functions. Last week we looked at exponential. This week we're going to look at logarithmic. And then we have a quiz, basically a mid-module check. So it's basically a quiz over last week's lesson and this week's lesson. So that's it. 1 assignment, 1 quiz. So let's look at 5.02 today. Switch over here. Logarithmic functions. All right, so starting out, we're going to look at Desmos, and we're going to look at why do we need to know about logarithmic equations. It's like, what in the world is a logarithmic equation? Why do we care? Well, because in math, there's lots of things that go together. Like when we have y equals 3x plus 2, right? When we graph this, there's an inverse equation. We have an inverse equation. Y equals x minus 2 divided by 3 is the inverse. Those are inverses of one another. And we can see that on a graph because when you have the inverse, they are a reflection over the line y equals x. So you see the green line is where y equals x. And these are reflections over that. That's like a mirror. It cuts it right down the middle. So these are inverses. Well, the inverse, we find the inverse of a lot of different things. When you multiply, you can find the inverse and dividing and all that. Well, with exponential equations, the logarithm is the inverse of it. And it talks about that right here. It shows the graph that we just looked at with the inverse of the function. But then it also talks about when we have an exponential equation, let's make it y equals 10 to the x, right? Remember, to be exponential, the x has to be in the exponent. So this graph looks like that. And if we do the logarithmic equivalent, y equals log x, there it is. It's an inverse. We can see that over the graph. It's reflected over the line, the green line, y equals x. So the red is the exponential. The purple is the logarithm of the same equation. That's the inverse of that. So we're going to be looking today at logarithm equations and how they relate to exponential equations. So we'll have some good things to write in our notes today. So I hope you got your pencil and paper out. But let's talk about, and I'm going to put it up on the screen like this. We're going to play with this. So if we have an exponential equation, and let's see, I'm going to write it like this. Y equals b to the power of x, right? So in this case, x is the exponent. And this is kind of a review of last week. The b is the base, right? So the base of the exponent. And y, I don't know if we talked about what y was last week. We should have. Is what we call the argument. And no, it's not because y yells at everybody and doesn't agree with anybody. That's not the argument we're talking about. But y is the argument. Now, when we have an exponent, we learned we could solve it if we get the bases to be the same and we can set the exponents to each other. But we also can convert this to a logarithm equation. So as a log, it would be the argument equals, and I'm going to write this part in pencil, log, and then the base followed by the argument. I color coded those for a reason. These are both bases. These are the arguments. Those are the exponents. But this is how we can take one and convert it to the other. So exponent, logarithm. So let's do an example of that. Let's say we have 16 equals 4 squared. That's right. We know 4 times 4 is 16. So we say, okay, that's true. But we could also write this in logarithmic form, in which case we could say, I'll put the logarithm first. Let's do it this way. Log base 4 of 16 equals 2. Those are the same. 4 squared 16, but if we take the log base 4 of 16, that equals 2. So basically what this is saying, when you have a base and an argument there, what power do we have to raise this to in order to equal that? 4 squared would be 16. To give an example, otherwise, let's, oh, and something else we can talk about. How about log 1,000? Log 1,000. What does that equal? You're like, Mr. Brock, you didn't give us a base. Oh, that's true. I did not give you a base because, like on our calculator, see, there's a log button right in there. That doesn't have a base. If you leave out the base, if you do not put anything down here in the subscript, it is assumed. We're like, assumed? Wait a minute. Do we assume in math? We do assume in math. Because when we say x equals 4, what's the coefficient of the x? Well, it's not there because we just assume it's a 1. We don't write, when it's a 1, we don't write 1x. We don't put 1x equals 4. The 1 is just assumed. Well, with a log, if we don't have a base, it's assumed to be base 10 because our number system is base 10, right? All of our numbers are base 10. We do decimals as 10th, 100th, 1000th. Our number system is base 10. So we assume that's a 10 if there's nothing there. So what is log 10 of 1,000? Well, if you remember how this works, log 4 of 16, 4 raised to the power of what equals 16? So we're saying 10, if we rewrite it in this form, 10 raised to the power of what, question mark, equals 1,000. Is that easier to think about? These are asking the same thing. 10 raised to what power equals 1,000? 10 raised to what power equals 1,000? Well, we know 10 squared is 100 because that's 10 times 10. But 100 times 10 is 1,000. So log of 1,000 equals 3 because 10 to the third power is 1,000. 10 to the third power. I'm going to sharpen this. All right. Keep us in business here. So that's how we use logarithms and exponents. We have to be able to go back and forth to help solve things because we don't always have something we can use. Now, we talked about the calculator. That log button. On this calculator, it's different. Some calculators, you hit the log button first. If I hit the log button first, it's assuming the 0 that's there. So I have to put the argument first. 1,000. And then I hit the log and it says, okay, I can tell you what the log of 1,000 is. It's 3, which we already talked about that. It is 3 log of 1,000. So on your calculators, when you just see the log button, that's assumed to be base 10. But what if I wanted to do this log 4 of 16? A lot of calculators have that capability also because this has a log. When I hit second, like shift, it has a log base. So if I want to say 16 log base, now it's wanting to know what base. Base 4. The answer is 2 because 4 squared is 16. But what if your calculator doesn't have that option? All you have is the log button. What are you going to do if you have to solve a logarithmic problem? Let's say you have, let's see, what's a good one? We'll just do something that's somewhat simple. Log 3 of 243. And you're like, that's simple, Mr. Brock? Well, it would be for a calculator. But you're saying, but my calculator doesn't have that other button. All I have is just the log 10, the log, just a normal log. All right. Well, there's something called the change of base formula. Change of base. All right, so this is great for your notes. If you don't have a button on your calculator, all you have is that log base 10, just the normal log button. That means we need to change this to where it's a log base 10 problem so you can put it in your calculator. Well, it's rather simple to do, and I'll tell you how. This is the same as log 243. Yes, we'll take this and put it on top. Divided by log of 3. We take the base and put it on bottom. Notice these are both base 10 because I didn't put a base on them. So if I have this, log 3 of 243, that's the same as the log base 10 of 243 divided by log base 10 of 3. Oh, well, I can do that on my calculator. Well, great. Let's do that. 243 log. Notice it's some kind of wild number there because 10 to the 2.38 power will equal 243. Divided by, and I want log 3. 3 log. Oh, the answer is 5. Does it really equal 5? Well, let's see. If we rewrote that, if it says log 3 of 243 equals 5, rewriting that as an exponent would be saying 3 to the 5th power equals 243. Remember, because we can rewrite it. Take the base. The base is still the base. The base of the log is the base of your exponent, so the 3. The x is the answer over here, the exponent. So 3 to the 5th equals 243. Well, let's check that. So 3 times 3 times 3 times 3 times 3. That's it. 5 3s. 243. Yes, 3 to the 5th power does equal 243. So this change of base formula works. Well, it really works better than you even think, because I could also say, well, log 14 of 243 divided by log 14 of 3. That's going to equal 5. When I change the base, that 3, I can change it to 10, I can change it to 14, I can change it to base 2, I can change it to base 5. It doesn't matter what base I change it to, as long as I use the same base. And as long as this goes on top and it's divided by this on the bottom. So log 243 with base 14 divided by log 3 of base 14 is still going to equal 5. Just like it equals 5 there, just like it equals 5 there, it equals 5. Because once it equals 5, it always equals 5. But the change of base formula is great to have in your notes, that I can take a log with a weird base and just make it base 10 if I want to. Any base. Now let me show you. We was talking about the calculator. It has that log button. There's another button underneath it, LN. You ever wonder what that is? It's like, wait a minute. Well, that's another logarithm button. LN. That is the same thing as logarithm base E. Base E? We're putting a variable as our base. No, that's not a variable. Not in mathematics. In mathematics, E is a number. We've talked about this before. We talked about this when we were doing exponents. Exponential last week. Remember, E is on our calculator also. And if I hit the button, it'll tell me what E equals. E equals 2.71828182845904523 ... It's like pi. It goes on forever. It doesn't repeat. E is a number. So E is called the natural number. I don't know why. They found it naturally occurring in something. And so this is called the natural log. Natural log. Natural log. Boy, that got to work on my writing. Natural log. Natural log, log base E. That's what that means. So it means we could have used the change of base formula up here to say instead of log 3 of 243, that could be the same as ln 243 divided by ln of 3. Because that's just changing the base to base e. When we put that in our calculator, we'll see that 243 natural log divided by 3 natural log still equals 5. We can change it to any base, including base e. So when you see ln, don't freak out. It's just a logarithm. It's just base e. So we generally don't write log e. We write ln because that's natural log. That's been accepted as being natural log. So let me highlight that for our notes. That means base e. All right, let me circle it. There we go. We'll box that in. Natural log. All right, so we need to use some of this and practice some actual problems that we might see. Let's see if we're missing anything in Buzz here that they're saying differently. Log 2 of 128, they're saying that's 2 to the 7th. They're just showing how to rewrite it. We already did rewriting. But you can go through this. I'm trying not to repeat everything the lesson does, so you can go through the lesson and get other information other than what I said. Log 3 of 9, 3 to what power equals 9? 2, right? Because that's the same as 3 squared equals 9. So created exponential functions, they look at a table. 2, 4, 8, 16, 1, 2, 3, 4. So you notice over here it's doubling times 2 times 2 times 2. See, it's not constant. It's not because it's plus 2, plus 4, plus 8, but it's the same as times 2. Over here is constant plus 1. So this is obviously log base 2 because in the exponent, it'd be 2 to a certain power because that's the number that's it's going up every time. The base is 2 times 2. So that is the points that would be on the graph of log base 2 of x. All right. And this one does the same thing with the natural log. So this says ln x equals 3. So they're doing the natural log. We're going to actually solve some problems here, though. So I'm going to solve this example right here because we want to see how do we use this. All right. It's nice that we have all these lovely notes, but how do we actually use this? When you give me a problem to do, what am I going to do, Mr. Brock? Well, we're going to do this. So if I said log base b of 32 equals 5, and I said solve for b. Tell me what base that is. I'm like, ooh, well, let's see. Generally, when you solve a logarithm, unless you can type it in your calculator, and this, since we don't know the base, we can't put that in the calculator. We need to rewrite it. We need to go back to this rule and say, okay, so I need to rewrite the base as the base, the exponent as the exponent, argument as argument. Okay. So the base is the base. So this would rewrite as b. The exponent is 5. So b to the 5th power equals 32. Okay. So now we're just solving an exponential equation. I'm trying to figure out what b equals. Right now I've got b to the 5th power. So if I take the 5th root, right, if that was squared, we'd take the square root. If it was cubed, we'd take the cube root. Since it's to the 5th power, we're taking the 5th root. We got to do it to both sides. So that will be b, because 5th root and to the 5th power cancel each other out. What is the 5th root of 32? Well, I could do that on most of the calculators to do that. See, there's the square root. But if I shift that second button, it has 3rd root and a y root where I can put in whatever root I want. So if I want 32 and I click that y root, it says, okay, what root are we using? We're doing the 5th root. It's a 2. It's a 2. So b equals 2 because 2 to the 5th power equals 32. So that'd be 2 times 2 times 2 times 2 times 2, 5 times. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is that works out. 2 to the 5th power. So that's how we can use it to solve. We have a logarithm, we can rewrite it as an exponent and solve the exponent. All right, let's do a different kind of problem that might be a little more life practical. It's like, oh, life practical. We kind of like that. All right, let's say you're planning on buying a car. And you've saved up money from working summers for Uncle Big Bucks or whoever you worked for. And you've saved up, let's say you've saved up $8,000. All right, you did pretty good. You saved $8,000. And you've got a place that you can go put that money in, just invest that money, and it will make 8% a year, and they will give you interest monthly. Every month they'll give you your month's worth of interest on your $8,000 at 8%. And you want to know, you say, if I can get $10,000, I can buy this car. So we want to have $10,000. And we have that formula that we studied last week that says the amount of money, when you invest it, you take the principal 1 plus the rate divided by the number of times a year you get interest times that same number times time, all right, times time. And we can figure out how much money. If I invest $1,000 at 8% interest, I get paid every month. What do I have after 5 years? I make the T 5, right? Well, in this case, I don't know T. All I know is I want $10,000. My dollar sign ran into my 1 there. I want $10,000 so I can buy this car. I've only got $8,000, but I'm going to make 8% a year. How long is it going to take me to have $10,000 if I don't have a job anymore? Now I'm just focused on school. I'm not working anymore, but I've got $8,000. I'm just going to put it in this investment, and it's going to make 8% a year. How long is it going to take me to get $10,000? Well, let's substitute what we know in here. We know we want the amount to be $10,000. That's what we want. And we know we have $8,000. And the interest is 1 plus 8%. Remember, we're going to put it as a decimal, 0.08. And we know we're going to get it monthly, so that's 12 times a year. And so 12t is what the power is being raised for. So we have everything except t, so we can solve this for t now, since we only have one variable. So we're going to solve this for t. So let's do order of operations. Probably the first thing we need to do is figure out what this number in the parentheses is. So we're going to have 10,000 equals 8,000 times. Let's see what that number in the parentheses is. I probably shouldn't put that second parentheses because I don't know how big the number is going to be yet. All right, so let's pull up our calculator again and say, all right, what is 0.08 divided by 12? And then we'll add 1 to it. 0.08 divided by 12. Oh, that's 0.00666666 forever. Add 1 to that because it's 1 plus that number. 1 point, okay, so the number in the parentheses is 1.0. Oh, I got 2 zeros. I put a 6 too early. 20667. I'll go that many there. That's a bunch of numbers past the decimal. All raised to the power of 12t. And you're going to have a problem like this, probably on the quiz too, but I know on the assignment this week there's a similar problem. So knowing how to do this would be really good. We're trying to get t by itself because that's what we're solving for. How much time is it going to take? So right now we've got 8,000 times this number being raised to 12t. So let's divide both sides by 8,000 to get rid of that number. So now what do we have over here? We have 10,000 divided by 8,000 equals 1.25. And over here, we still have the 1.0066667 raised to the power of 12t. Okay, now we know that if we could have the bases the same, we could solve that as an exponential equation. But I don't have the foggiest idea how to get those bases the same. Anybody? So if we can't make those the same, because I wouldn't even know how to do that. You know, if it was a 2 and a 4, we could do it. 2 and 2 squared. Instead, we're going to go the other direction then. We've got this. We're going to write it as a logarithm. So the log, the base is the base. This is the base. So it becomes the base here. Base 1, 0, 0, 6, 6, 6, 7 of 1.25 equals 12t. All right, the 12t, which was the exponent, becomes what the log equals. So the log of that base of the argument 1.25 is 12t. And let's go ahead and find what this is first. So we have our calculator that we can take this. If we just have the simple calculator, remember, we can always do change of base. So let's do that. Let's say, okay, so log of 1.25 divided by log of 1.006667 equals 12t. So I just did change of base just to make it easy to punch in the calculator. So let's find out what that equals, because that's a number. 1.25 log divided by 1.006667. So this equals 0.0962. How far are we going to go? 268. How about that? That's a bunch of decimals. Equals 12t. 0.09. So if we divide this, did we do that right? Did I hit equals? Yeah. Oh, I didn't hit log. That's not it at all. I just divided it by 1.0667. I forgot to hit the log. I'm looking at my calculator up here. It says log 1.25 divided by 1.06667. No. 1.25 log divided by 1.006667 log. I got to take the log of that as well. So that actually equals 33.5813. Let's do that many decimals. 33.58. And if I divide both sides by 12, I'll figure out how many years. So let's take, well, we got it on the calculator. Let's just divide it by 12. So in about 2.8 years, that $8,000 will grow to be $10,000. So if I want to wait 2.8 years, I can have that $10,000 to put as a down payment on a car or to buy a car outright for a used car. But it takes 2.8 years for $8,000 to turn into $10,000 if you're getting 8% and getting monthly interest. Yeah, I didn't hit the log button. I just divided 1.25 by this number. The log of 1.25. Got to hit the log on both of them. All right, 2.8 years. So that is a way to use logarithms and exponential equations back and forth to be able to solve problems. So this talks about the change of base formula. We've already gone over that, but here it is. So when you want to go back through this lesson and see what else it talks about, log b of y. I don't know what did I use? I did. I just used actual numbers. Log b of y is the same as log y divided by log b. Change of base. All right, so change it to any base. Okay, and then it talks about the natural log, which we talked about, which is base e. Oh, and then you want to check your work. What is the natural log of 9? Okay, well, let's do that. It says round to 3 decimals. It wants to know if you know how to do it in your calculator. So if I say 9 natural log, that equals 0.018. What was the other number? 3. Oh, 0.18, not 0. 0.183. Submit. Ah, now let's see if I take off the 0, if it tells me. Take a look at the correct answer. 2.197. Natural log of 9. Oh, why is it divided by 12? Wait a minute. Natural log of 9. Oh, yeah, it's 2.197. I don't know why I divided it by 12. Natural log of 9 is 2.197. That's correct. All you got to do is hit the 9, hit the natural log button. 2.197. All right. And on there, it shows how you can do it with a change of base. Log 9 divided by log e, natural log of e, which the natural log of e is 1, because e to the first power equals e. All right, so change of base. It gives you some more examples if you need it. Change of base for common log. So you can take log 715, make it log 15 over 7, over log 15 over log 7. So more examples to show you what we already worked through. So like I said, I'm leaving it where you can go back to the lesson and see other things we didn't do. So here's one similar to what we just worked. You turn 16, you decide to put $50 in a savings account so you can put a $2,500 down payment. If you get 3% per year monthly, how long will it take you to have $2,500? And will you have enough money by your 18th birthday? Well, let me tell you, if you just put $50 in and you're making 3%, you're not going to have $2,500 by your 18th birthday. Let's see what it says. It takes everything, puts it in there for the numbers. Oh, and they're not even solving it yet because they're saying by the end of the lesson, you'll have the tools you need to solve it. We've already solved it on paper. We know the tools. 50 equals 1.02512t, but it'll be many, many years. Okay, here's another one example. I won't do this on paper because you have it right here in the lesson. Step 1, you have to take this and rewrite it as a logarithm. Log 7 of 4 equals x plus 1. The next step, you could do log 4 of 7 right there. You can do that as a change of base for your calculator. So log 4 divided by log 7 equals x plus 1. And then put those numbers in the calculator. Log 4 is 0.60205999. Log 7 is 0.84. When you divide them, you get 0.7124147. And then you subtract 1 because you want to get x by itself. So the answer is x is negative 0.288. Oh, here's the problem with the $50 in a savings account. Let's see about your 18th birthday. So here they work through the whole thing just like we did for just now. Well, there you go. It'll only take 130 years. Well, and another half. 130 years for your $50 to become $2,500. Yeah, you're probably going to need a job. Yeah, you're not going to want the car by the time you're 146 because you started when you're 16. And that car's going to cost a lot more in 130 years. So there you go. Yeah, you can't make that much money in savings. But that's the same problem. So if you need another example going through the same thing I did on paper, this problem right here, here's another example in our lesson with different numbers, starting with 50, trying to get 2,500 with 3% interest. So there's another example you can put in your notes or look through, make sure you understand it. And here's solve e to the 2x equals 30. So you need to rewrite that. Log e 30 equals 2x. Log e is the same thing as natural log. Natural log of 30, you can punch that in a calculator and then divide by 2. So there you go, 1.70. All right, I don't think there's much more on here that's new. I think we've covered about everything that we're going to see there. This gets back to the interest thing again and changing time increments. That it really is not a big thing because I looked at that and I said, I don't even know why you would do that because you can solve it without it. Here's our lesson summary. It talks about converting exponents to logs and logs to exponents and a change of base formula and solving exponential equations on an equal basis. You just write them as a log equation. We probably should do one of those as a sample, just one. So solving exponential equations with unequal bases. Oh yeah, we did something like that, but we'll do one on paper here. I'll do it over here. So we know if we can get the bases the same in an exponential, like if we had 5x equals 25, right? That's an easy one that we can solve as an exponential equation from last week because 25 is 5 squared, right? So we could rewrite this as 5x equals 5 squared because that's the same thing. I've made these the same base, so I can just set the exponents equal to each other, x equals 2. All right, that's easy. But what about when 5x equals 20? Okay, well, 20, we can't write as base 5. We're like, I have no idea. So that's when we want to rewrite this as a logarithm. Log base 5 of 20 equals x. This we can rewrite if we want to. Now we can put it in the calculator that way, or we can say log 20 divided by log 5 equals x. But either way, punch this in our calculator and get the answer. Let's pull up our calculator. Log 20 divided by log 5. The answer is x equals 1.8614. We'll round it at 4. Yes. Or we could do the log 520 if you have that capability, like there. 20 log base 5 gets the same answer. 1.8614. So it's basically saying 5 to the power of 1.8614 equals 20, which makes sense because we know if it was 5 to the second power, it'd equal 25, right? That was up here. 5 to the second power equals 25. So it should be a little less than 2 because 20 is less than 25. So we can say that's probably right. All right. That was it. You've got a couple of pages of practice problems. And then here's our assignment. Which logarithmic functions represent the data in this table? If the third term is 216, the fourth term is 1296, the fifth term 776. What's being done here? Is this log x of 5, log x of 6? Is this 3 to the fifth power equals 216? What power? What? So you got to figure out that. And if you need to punch those in calculators and see which ones work for those numbers, f of x, log x of 5. So log base 216 of 5, does that equal 3? Probably not. You may need to go to the next one. 6 times the log of 216, does that equal 3? Log 6 raised to the third power. Raised to the 216th power. Does that equal 3? Which one of those? If you substitute the x in and the f of x in, which one of these does it work? Okay, solve. Log of x equal 4. Which one of these numbers would x have to be? Remember, there's no log base written there, so that must be base 10. So log base 10 of x equals 4. Evaluate the natural log of 7. That can only be done with a calculator. And there's a calculator in Buzz. See, there's a button right up here. Calculator, right at the top. Calculate. Click that. There's a calculator. So there's a calculator right here in Buzz if you don't have one that you already like to use. I don't like the purple. It's hard to see, but let's see. Where's the log button? I don't even see a log button. Oh, there it is. There's log and there's natural log. And if I hit the shift, turns into exponents. So I only have log and natural log on here. Base 10 and base E. So I don't know if there's anything I can do about that. So you're going to need that change of base formula for the calculator that's included here in Buzz. If you have your own calculator, you may have one that could do more, but this one just has regular log. And on this one, you hit the log button first, like log 100, and then hit enter is 2. So you hit the log button first, and then say you want the log of what? The log of 96. That's 1.98. Okay. Solve 4 to the power of x plus 2 equals 12 for x, and use the change of base formula. Which one of those solves it? And here's another one of those where you put $5,000 in the savings account, trying to save up for $6,000. You get 7% per year, compounded monthly. How long does it take? 300 years, 31 years, 26 years, 2.6 years. 5 questions. Let's look at the quiz before we go. 5.03. Exponential and log functions mid-module check. So the instructions just say, do the check. Complete this. So if we go to the assignment, you get 2 attempts at the quiz. This has some of the stuff from last week, some of the stuff from this week. If 4 to x equals 8 to the x minus 1, try to get both those the same base, which you could do because you could do both those base 2. If you need to go back and look at last week's notes or last week's class video. All right, $625 invested at 7% per year, compounded continuously. So you're using that A equals PERT formula that we looked at last week. How much is it worth in 12 years? So both of those, and it tells you that these are from lesson 5.01. That's from last week's lesson, 5.01. And these are this week's 5.02. Solve log of x equals 3. Solve this. On the last one, you have to explain how to solve 4 to the x plus 3 equals 7 using the change of base formula and include the solution. Now, let me tell you, and that's the last problem there. Let me tell you, in math, a lot of times if it says explain, if I say explain how to solve this using the change of base, you could just work the problem showing all the steps for the change of base. And that's an explanation of math. If you're in English class, they want you to say, well, first what you need to do is you need to write the, like, you know, that's words. You can use words in a math explanation. That's fine. But if I said y equals 2x plus 3, that's a sentence in math, right? It's an equation. That says something. So when it says explain how, just show all the steps on how. Or you can type out all the steps, however you like to do that, whatever you prefer. But this is a math class, so I'll accept just math work as an explanation. All right, that's it, guys. Logarithms. Exponential last week, logarithms this week. They fit together and work real nicely as a pair. So there you go. And you have the quiz. That's it. We are not going to have a mandatory class on Friday. I'll have class on Friday. If anyone starts on this today and they say, okay, I'm not getting it, I'm stuck, and the lesson didn't help me, I went back and looked at that, I still don't get it. That's what I'm here for on Friday. You can come in and say, hey, Mr. Brock, I'm looking at this quiz and I'm lost on number 5. Okay, come see me. We'll talk about it. But otherwise, no mandatory class on Friday. Just optional class on Friday. All right, guys, I'll let you go. We're right at an hour today. Have a great week.